inverse cosine function. See, last session we have seen what you mean by inverse sine function, and we have analyzed, and finally we came to the conclusion that inverse sine function is defined, means sine inverse x is defined only when x lies between -1 and +1, and sine inverse x must lie between -π/2 to +π/2. And we have seen different examples, and the graph of sine inverse x versus x also we have seen. And you may recall the graph of sine inverse x versus x. This is x and this is sine inverse x, and maximum value of in sine inverse x, maximum value of x is 1, minimum value of x is -1, and maximum value of sine inverse x is π/2, and minimum value of sine inverse x is -π/2. As such, the entire graph must be contained in this rectangle, and the graph goes like this. Like this. This is a graph of sine inverse x versus x. And finally, we have seen one result also. Sine inverse minus k is equal to minus sine inverse k. Just you have to pull out this minus and outside. How to recall instantly. This is the way. This is about sine inverse x graph. Now, on similar grounds, we will analyze the inverse cosine function. And as I have said, entire inverse trigonometric function is pivoted on a simple concept that inverse exists, inverse function exists only for a bijective function. On this basis, we will take a simple function, that is cos mapping a real number set into a set which contains all the elements between -1 and +1, closed interval. Roughly I have taken, because we don't have any idea, because look at this, this is set A and this is set B. You are 100% sure that cosine value, cos of any angle will not be more than 1, will not be less than -1. You are sure about that. That's why set B already we have restricted it between -1 and +1. Okay, 1, half, 0, -half, -1. Just representative values I have shown. In between there are so many values. And set A is all real numbers. Any angle, say 0 degree, 60 degree, 90 degree, 120 degree, 180 degree, 240 degree, 300 degree, 360 degree, and say you take -60 as well. You have all the angles, all representative angles from all 4 quadrants. You can include any number of angles because set A is real number set. And this is cosine function. And cos 0 is 1, cos 60 is half, cos 90 is 0, cos 120 is -half, cos 180 is -1, cos 240, it's third quadrant, this is -half. It's enough to say that it's not bijective, because it is not 1, 1. The status of 1, 1 is lost. If it is not 1, 1, no longer it can be bijective. You know, bijective function is a function which is both 1, 1 as well as onto. This is not 1, 1, therefore it cannot be a bijective function. Hence, inverse function does not exist for this type of cosine function. If you take set A as real number set, it is true that cosine of that angle is defined. It is there in set B, but it is not 1, 1 function. It is not bijective. Therefore, inverse function does not exist if you define cosine function like this. Go for different possibilities. Modify. As I said, if you consider different inverse trigonometric functions like inverse sine function, it's a game. Inverse cosine function, game. Inverse tangent function, it's a game. Games will be very interesting when you impose rules and regulations on that. So this is the high time where you have got to introduce some rules on this. What is that rule? Let us see. Now you consider, when you consider cosine function in this way, you find that inverse does not exist. We'll modify. So what we'll do is cosine function mapping, say for example, a set which contains all the angles between minus pi by 2 to plus pi by 2 into all the values between minus 1 and plus 1. Now the question is, what made you to take like this? Maybe we might have drawn the inspiration from sine function. Let us see whether it holds good or not. If you consider like this, a, b, this is a function, no doubt. This one is a function. But whether inverse exists for that or not, we have to check. Okay, minus 90, minus 60, 0, 60 and 90. Let us see. And we will take minus 1 and this is minus half, 0, half and 1. Okay, this is cosine function. Let us see. Cos of minus 90, cos of minus theta is cos theta, so it is 0. And cos of minus 60 is cos 60, which is half. Cos 60 is also half. No longer it is 1, 1. Hence not bijective. Hence inverse does not exist. So this possibility, this option cannot be considered for inverse function. Not possible. Then, trial and error method. Somebody has already done it so many years back. We are just trying to analyze in what way they have come to a conclusion finally. Look at this. So you consider a set which contains all the angles between 0 to pi into a set which contains all the elements between minus 1 and plus 1. Look at this. Set A, set B, 0, 60 degree, 90 degree, 120 degree, 180 degree. And this will be 1, half, 0, minus half, minus 1. See, we are putting certain restriction on set A. That restriction is you have to contain the angle in angles in set A to be between 0 to pi inclusive. Now this is the cos function. Cos 0 is equal to 1, cos 60 is half, cos 90 is 0, cos 120 is minus cos 60, second quadrant, minus half, cos 180 is minus 1. Any two angles, if you take between 0 to 180, cosine of those two angles cannot be same. Means there will not be any convergence. Means it cannot be 1, 1. It cannot be, it has to be 1, 1. I repeat again, if there is any confusion. Any two angles between 0 to 180 if you select, cosine of those two angles cannot be same, which enables it to be 1, 1. Means it is eligible to become bijective function. Similarly, if you select any value between 1 and minus 1, any value between 1 and minus 1, what do you mean by select any value between 1 and minus 1? Say for example, root 3 by 2 you take. Root 3 by 2 comes here, 0.866. Root 3 by 2 is the image of one angle here, that is 30 degree. And image of root 3 by 2 is only 30 degree. No other image it has. This is the image of only 30 degree. This is not the image of any other angle between 0 to 180. Like that, if you select any value between 1 and minus 1, that is the image of some element of set A, which clearly says that no element of set B is left out. Hence it is onto. We already said it is 1, 1. Right now I am telling it is onto as well. Hence it is bijective, because a bijective function is a function which is both 1, 1 as well as onto. Therefore, you can straight away say that inverse exists for this because this is a bijective function. So, inverse exists. So, once you define like that, cos inverse is mapping between minus 1 to plus 1 into a set which contains all the elements between 0 to pi. It goes like this. Look at this. This is set A. This is, of course, now it becomes set B. This is set A. This is cos inverse. Look at this. 1 half, 0, minus half, minus 1. 0, 60 degree, 90 degree, 120 degree and 180 degree, and 1 is the image of 0, half is the image of 60, 0 is the image of 90, like this. So this is also a bijective function. You know, inverse exists only for a bijective function, and inverse of a function when it exists, that is also bijective. Out of this discussion, what you can make out is cos inverse x exists when x lies between minus 1 and plus 1. Look at this. 1 and minus 1. And cos inverse x is an angle. I told you yesterday in the last class that inverse function, inverse trigonometric function answer is always an angle. Instantly, if at all you have got to recall cos inverse x, tan inverse x, sin inverse x, what are these? They are all angles. So you find that cos inverse x is an angle between 0 and pi. Under any circumstances, cos inverse x answer cannot be in third quadrant. It cannot be in fourth quadrant. It has to be either in first quadrant or in second quadrant. And if you draw the kingdom of variation of cos inverse x varies like this. So it is between 0 to pi. Cos inverse of something is equal to 240 degree, wrong. Cos inverse of something equals minus 45 degree, absolutely wrong. Cos inverse of something 120 degree can be. Cos inverse something 90 degree, cos inverse something 0, cos inverse something 45 degree, possible. Cos inverse something 300 degree, no. That's what I am telling. It goes strictly according to the what we have analyzed. What is what we have analyzed? Out of this full analysis, what you need to remember is, finally, cos inverse x is an angle which lies between 0 to pi. And in cos inverse x, x is there, no? That is a value which lies between minus 1 and plus 1. Okay. Further, if you analyze, you find that these are all x values, these are all cos inverse x, and this is the function x cos inverse x. You find that here x is all positive, at least non-negative, nothing wrong. Strictly speaking, 0 is not positive, but practically we take 0 under the category of positive. Okay, anyways, this is non-negative, this is negative, that is for sure. When x is non-negative, you find that angles lie in the first quadrant, cos inverse x lies in the first quadrant. And when x is negative, you find that angle is in the second quadrant. So cos inverse positive, first quadrant, cos inverse negative, second quadrant. Remember that. I said cos inverse x must be an angle either in first quadrant or second quadrant. Cos inverse positive, first quadrant angle. Cos inverse negative, second quadrant angle. Okay. So that's what. Let me classify. If x is greater than or equal to 0, then means x is non-negative. Cos inverse x is an angle in the first quadrant. First quadrant angle representation is cos inverse x lying between 0 and pi by 2. And if x is negative, look at this, x is negative, then cos inverse x is an angle in second quadrant. Cos inverse x lies greater than 0, no, greater than pi by 2, less than or equal to pi. This is the representation of second quadrant angle. Greater than pi by 2, less than or equal to pi. Let us take different examples, then it will be clear. What is that? Cos inverse half. Cos inverse half is equal to pi by 3 because cos pi by 3 is half. Cos inverse positive, first quadrant. Cos inverse of root 3 by 2, that's equal to pi by 6. Then cos inverse of pi by 4, cos inverse of 1 by root 2. Come on, how much is this? Pi by 4, because cos pi by 4 is 1 by root 2. Next, cos inverse of 1, that's equal to 0 because cos 0 is 1. Cos inverse of 0, that's equal to pi by 2 because cos pi by 2 is 0. Next, cos inverse of root 3 minus 1 by 2 root 2, that's equal to 5 pi by 12. Cos 75 is root 3 minus 1 by 2 root 2. Similarly, we have cos inverse of root 3 plus 1 divided by 2 root 2, that's equal to just pi by 12. Then let us take negative in cos inverse x. When x becomes negative, what happens? We'll see. Cos inverse of minus half. How much? You said minus. No. It cannot be minus. Angle, if you say minus something, say minus, if you say pi by 3, cos inverse answer cannot be in fourth quadrant. Cos inverse negative has to be in second quadrant. Cos inverse positive is in first quadrant. So this has to be in second quadrant. Cos inverse negative, look at this, here we have written, if x is negative, cos inverse x is an angle between pi by 2 and pi, means in the second quadrant. So how do you write? It's not minus. If you write minus something, the meaning is angle is in the fourth quadrant. But the angle must be in the second quadrant. How do you give the second quadrant angle? Standard representation of second quadrant angle is always pi minus something. Look at this. Pi minus something. That's a way in which you have got to represent the second quadrant angle. Okay. So pi minus how much? Pi by 3. That's equal to 2 pi by 3. Then cos inverse of minus root 3 by 2. That's equal to in the same style. Come on. Pi minus pi by 6. That's equal to 5 pi by 6. Correct. Cos inverse of minus 1 by root 2. That's equal to pi minus. Whenever you get cos inverse of minus, it has to be pi minus. Pi minus pi by 4. That's equal to 3 pi by 4. Cos inverse of minus 1. Pi minus 1. It's 0. Cos 0 is 1. So pi minus 0. That's equal to pi. Cos pi is minus 1. Even otherwise. Next, cos inverse of 1 minus root 3 divided by 2 root 2. 2 root 2. That's equal, that equals to, say, minus of, I can write like this, root 3 minus 1 divided by 2 root 2, that's equal to cos inverse of negative. That's equal to pi minus 5 pi by 12. That's equal to 7 pi by 12. You can generalize, on the base of this, you can generalize that, look at this and look at this. Say, for example, cos inverse 1 by root 2, pi by 4. Cos inverse minus 1 by root 2, pi minus pi by 4. So, in general, cos inverse of minus k is equal to pi minus cos inverse of k. Say, if you take example, cos inverse of 1 by 2 minus 1 by 2 equals pi minus cos inverse 1 by 2. That's equal to pi minus pi by 3, that's equal to 2 pi by 3. You must have the fluency. How you are very fluent with cos 60 is half, cos 90 is 0, cos 30 is root 3 by 2, like that. You need to be very fluent with cos inverse of half, cos inverse of minus root 3 by 2. You need to be very, very fluent. If you are not fluent, then game will not be interesting. Okay, now on the base of this, let us see how will be the graph of cos. Okay, out of this discussion, what you need to remember, important thing, what you need to remember is cos inverse x is an angle between 0 and pi. So further, cos inverse positive first quadrant angle, cos inverse negative second quadrant angle. One is that. Then cos inverse of minus k is equal to pi minus cos inverse k. Okay, now let us see the graph of cos inverse x versus x. Graph of cos inverse x versus x. How it will go? Let us see. See the graph, this is cos inverse x and this is x. In cos inverse x, maximum value of cos inverse x, it's an angle, pi. Okay, pi. This is pi. Minimum value is 0. It lies between 0 to pi. Look at this, 0 to pi, 0. And just for our reference, pi by 2, halfway through. And in cos inverse x, maximum value of x is how much? I'll repeat. In cos inverse x, maximum value of x is 1, right? It is 1. And minimum value of x is minus 1. See, this is 1 and this is minus 1. X is equal to 1, x is equal to minus 1. And on the base of what analysis we have done, you tell me the values. Cos inverse 0. Cos inverse 0 is pi by 2. Cos inverse 1 is 0. Cos inverse minus 1, this is pi. And in between you have got so many values. Say cos inverse 1 by 2 is equal to pi by 3. Pi by 3 is somewhere here. Cos inverse minus half is here. Cos inverse minus half is equal to pi minus cos inverse half. That's equal to pi minus pi by 3, 2 pi by 3, 120. 120 comes somewhere here because this is 90, 120, this is 180. And if you draw the graph, you get a graph like this. Look at this. The graph will be like this. Once again, one doubt arises at this stage. See, look at this. This is cos inverse x, and this is x, and this is pi, this is pi by 2, and this is 0, this is 1, and this is minus 1. Now one point is here, one point is here, one point is here. Cos inverse 0 is pi by 2, cos inverse 1 is 0, cos inverse minus 1 is pi. Now the question is, why can't the graph be like this? I have preferred to write the graph like this. Look at this. If you draw the graph like this, then the tangent at the point x equals 1 will be parallel to x-axis. But tangent at the point x is equal to 1 has to be perpendicular to x-axis. Same analysis we have done in sine inverse x. I told you to remind the teacher when we are in the process of doing applications of derivatives, especially tangents and normals. You will get a fair idea why the graph has to be like this, why it should not be like this. Same situation we have. You need to remind the teacher when they do the topic called tangents and normals under applications of derivatives. Just remind them, sir, sine inverse x, cos inverse graph, you told us to remind why the graph has to be like this, why it should not be like this. Okay, very important. And by looking at the graph, it is very easy to tell what you mean by domain and what is range. Tell me what is the domain here. Domain means what are the possible values of x. What are the possible values in set A in that bijective function? You know it is only between minus 1 and plus 1, domain. And range. Range values are anything between 0 to pi, you know. So this is nothing but the different informations about cos inverse x. Once again, the gist of what we have discussed today is cos inverse x is an angle between 0 to pi. Cos inverse positive is in first quadrant, cos inverse negative is in second quadrant, and cos inverse minus k is pi minus cos inverse k, and the graph of cos inverse x versus x is like this, and domain is this, between minus 1 and plus 1, and range is between 0 to pi. So inverse sine function and then inverse cosine function. And at the end of the analysis of inverse sine function, we could come to the conclusion that sine inverse x lies between, it's an angle which lies between minus pi by 2 to plus pi by 2, and where x lies between minus 1 and plus 1. And cos inverse x lies between 0 and pi, either in first quadrant or in second quadrant, where x lies between minus 1 and plus 1. Sine inverse positive first quadrant, sine inverse negative fourth quadrant, cos inverse positive first quadrant, cos inverse negative second quadrant. So this much we have discussed, and we have analyzed the graph of sine inverse x versus sine inverse x versus x, and you know maximum value of x is 1, minimum value is minus 1, maximum value of sine inverse x is pi by 2, minimum value is minus pi by 2, this is 0, this is x is 1, this is x is minus 1. And the graph was like this, you may recall, and I said the tangent at this point must be perpendicular to x-axis. And domain is a closed interval, a set containing all the values of x between minus 1 and plus 1, and range is all the angles between minus pi by 2 to plus pi by 2. And in cos inverse x, this is x, and this is cos inverse x. Cos inverse x lies between 0 to pi. Last classes, that is about sine inverse x and then cos inverse x. Continuing with this, we will see how this tan inverse x behaves. The origin of tan inverse x we will see. So, see, in order to analyze the variation of sine inverse x versus x, we started with the fundamental variation of sin x versus x, and then we check whether it is a bijective. If it was not bijective, we made it bijective by modifying the set A and set B, and then we, once we made it bijective, then we defined sine inverse x. Same style in cos inverse x. We have taken the variation of cos x versus x, and then we checked whether it is a bijective function, and it was not bijective function, and by modifying the sets, we made it a bijective function, and then hence we define cos inverse x. Let us analyze about tan inverse x. Okay, before going ahead with that, we will see f maps A into B. F that it is not defined. Infinity is not defined as a finite quantity. If you don't tell infinity, then you won't get the idea that it's a very large. Generally, the infinity concept gives us the idea that it is infinite, it is very high, it is more, not finite, beyond that. Instead of just telling not defined, infinity gives the idea that it is infinite. Countless, that's the meaning of infinity. And in tangent function analysis, infinity will come into picture very frequently. Okay, how is that? We'll see. I have taken set A as real number set A, and this is set B. The tangent function which maps real number set into real number union minus infinity comma plus infinity. Means any variation between minus infinity and plus infinity, let us consider. And this is set A, this is set B, this is tan function. Let me take different angles, say 0 degree, then 45 degree, 90 degree, 135 degree, 180 degree, 225 degree, 270 degree, then let us see 315 degree, 360 degree. You have almost all the angles of different quadrants, and let us take different values here. Minus infinity, minus 1, 0, 1, infinity. You have got so many other values in between, just representative values I have taken. Tan 0 is 0, tan 180 is also 0, you know. So, it is not 1, 1. If it is not 1, 1, it cannot be bijective. If it is not bijective, inverse function does not exist. Not only this, there are so many other things like tan 270 is equal to plus or minus infinity. Look at this. But in tangent function, 270 degree is not an element of domain. 270 degree you can't consider in tangent function. When you analyze the graph of tan theta versus theta, and when you say what is the domain and range, in that domain 3 pi by 2 is not there. In fact, odd multiple of pi by 2 is not there. Okay, you forget about that. Tan 0 is 0, tan 180 is 0. It does, because there is a convergence. If it is not 1, 1, it is not bijective. If it is not bijective, inverse will not exist. So, just like what we have analyzed in sine and cos, we may have to modify this. We will modify, and by trial and error method, finally we will modify like this, minus pi by 2 to plus pi by 2. We will see what happens. A set contains all the values between minus pi by 2 and plus pi by 2. Look at this. This is set A, this is set B, this is minus 90, minus 45, 0, 45, 90, and minus infinity, minus 1, 0, 1 and infinity, and this is tan function. Tan of minus 90 equals, tan of minus theta is minus tan theta, minus tan 90, tan of minus 90 is minus tan 90, minus tan 90, that is equal to minus tan 90 is infinity, minus infinity. Sometimes it may look wrong, because tan 90 is not defined as a finite quantity, then how can you equate? It's a just rough analysis. In fact, we can't write it as closed interval. We should have written it as open interval. Okay, for the timing, let it be like this. Our intention is how tan inverse x function is introduced. Any modification we will do it later. Tan of minus 45 is minus tan 45, tan 0 is 0, tan 45 is 1, tan 90 is equal to infinity. Tan 90 is equal to infinity. Now the question is, You may say tan 90 is plus or minus infinity. 90 minus 0 first quadrant, 90 plus 0 second quadrant. But 90 plus 0 you are not supposed to peep into. You are not supposed to peep into second quadrant. 90 plus 0, then only you will get minus infinity. But you can't take 90 plus 0 because you are supposed to restrict set A between minus pi by 2 and plus pi by 2 closed interval. Pi by 2 plus 0 means what? You are looking beyond pi by 2, which it is restricted up till pi by 2. So tan pi by 2 minus 0, it is in first quadrant, it is infinity. So between minus 90 and plus 90, if you take any two angles, tan of those two angles will not have same answer. In other words, there is no convergence from set A to set B. It's 1, 1. Similarly, set B if we consider, you have values between minus infinity and plus infinity. Any particular value if you take, then that is the image of one element of set A. If you take root 3, here, root 3 is 1.7321 and that is the image of 60 degree. 1 by root 3 if you take, that exists, no? It's a real number. 1 by root 3 is the image of 30 degree. And this is not the image of any other element, hence it is 1, 1. And any value between minus infinity and plus infinity if you take, that is the image of one element of set A. No element of set B is left out, it is onto 1, 1 as well as onto, hence it is bijective. So inverse exists for this. If you modify set A like this, inverse exists. How you can say, then how can you say in tan inverse? Tan inverse mapping R union minus infinity comma plus infinity into a set which contains minus pi by 2 comma plus pi by 2. I said it is an open interval. It has to be open interval, closed interval, open interval. Because if you consider closed interval, 90 degree you have got to consider. Tan 90 is not defined as a finite value. Infinity cannot be an element of a set. Infinity cannot be an element of a set. So let us consider inverse exists for this. So tan inverse maps R union minus infinity comma infinity into minus pi by 2 comma plus pi by 2. In that case, how it goes? Set B is here and set A is here. Set B is minus infinity, minus 1, 0, 1 infinity, and this is minus 90, minus 45, 0, 45 and 90. Okay, this is tan inverse. Tan inverse of minus infinity is minus 90, tan inverse of minus 1 is minus 45, tan 0 is 0, tan inverse of 1 is 45 degree, tan inverse infinity is equal to 90 degree. On the basis of this, you can say that tan inverse x exists because it exists only for a bijective function. We have made the tan function bijective in this way, and hence tan inverse is defined like this. Tan inverse x lies between minus pi by 2 and plus pi by 2. This is the kingdom of tan inverse x. Look at this. This is tan inverse x. So this is between minus pi by 2 and plus pi by 2. Tan inverse of anything, it must be an angle either in first quadrant or in fourth quadrant. Tan inverse something, 45 degree, right. Tan inverse something, minus 60 degree, correct. Tan inverse something, 89 degree, correct. Tan inverse something, minus 88 point something, correct. Tan inverse something, 120 degree, wrong. Because 120 degree is in second quadrant. Tan inverse something cannot be in second quadrant. Tan inverse something is equal to 240 degree. No, absolutely wrong. Immediately how to tell, instantly. It must be like reflex action. Tan inverse something 240 degree. No, cannot be. Infinity and plus infinity. But there is no meaning for writing equal to infinity. Infinity is not a finite quantity, then how can you equate something to infinity? So roughly it is okay, but precisely this is correct. Or the other way of writing this is x is any real number. X can take any value, there is no exception for values of x. But tan inverse x always lies between minus pi by 2 and plus pi by 2. There is no equal to. Since we have not written equal to, here also you can't write equal to. Tan inverse something is equal to 90 degree, not possible. It cannot take the value of 90 degree. We will draw the graph of tan inverse x versus x, then you will get a precise idea. Now, you find that, see, here they are all negative values of x. This is x and this is tan inverse x and the function is tan inverse. These are all values of x. See, x is negative, x is non-negative. When x is negative, answer is in fourth quadrant. X is non-negative, answer is in first quadrant. X is negative, tan inverse x is in fourth quadrant. X is non-negative, tan inverse non-negative is in first quadrant. Write that very clearly. Tan inverse x lies between minus pi by 2 and plus pi by 2. Further, if x is greater than or equal to 0, tan inverse x is an angle between 0 and pi by 2. Not equal to, less than pi by 2, first quadrant angle. If x is negative, less than 0, as you can see here, then tan inverse x is an angle in the fourth quadrant. You can see here, fourth quadrant. Less than 0, greater than minus pi by 2. Let us take different examples. Tan inverse of 1, that's equal to pi by 4. Tan inverse of root 3, that's equal to pi by 3. Tan inverse of 1 by root 3, that's equal to pi by 6. Tan inverse of 2 minus root 3, that's equal to pi by 12. Tan inverse of 2 plus root 3, that's equal to 5 pi by 12, and so on. And tan inverse minus 1, tan inverse negative is in fourth quadrant, I said. Tan inverse minus 1 is minus pi by 4, minus pi by 3. Tan inverse of minus 1 by root 3 is equal to minus pi by 6. Tan inverse of root 3 minus 2 is as good as tan inverse of minus of 2 minus root 3, that's equal to minus of pi by 12. By comparing these two, you can come to a conclusion that tan inverse of minus k is equal to minus tan inverse k. Look at this. We will take example, no? Tan inverse of minus 1 is equal to minus tan inverse 1, that's equal to minus pi by 4. Just like sin inverse of minus k is minus sin inverse k. Tan inverse of minus k is minus tan inverse k. Cos inverse of minus k is not minus cos inverse k, it is pi minus cos inverse k. Okay. Now, let us see the graph of tan inverse x versus x. Once again, I repeat, out of this analysis, what you must conclude is tan inverse x is an angle between minus 90 and plus 90, where x is any real number. Tan inverse positive is in first quadrant, tan inverse negative is in fourth quadrant. Out of this analysis, you need to remember that. Okay, we will try to draw the graph of tan inverse x versus x. This is x and this is tan inverse x. And just now you have written tan inverse x is a graph, tan inverse x is an angle which lies between minus pi by 2 and plus pi by 2. Maximum value is pi by 2, minimum value is pi by minus pi by 2. This is pi by 2 and this is minus pi by 2, 0. And you can't write a vertical line, unlike in case of sin inverse x and cos inverse x. Because there you had the condition on x, x can vary between minus 1 and plus 1 only. It cannot be beyond 1, it cannot be less than minus 1. But tan inverse x, in that x can take any real value. Any real value, positive side, negative side, any real value. Where you will put any vertical line? If you put any vertical line, the meaning is you are restricting the value of x. But there is no restriction on value of x in tan inverse x. X can take any real value. As such, there is no vertical line here at all. Tan inverse 0 is 0 and tan inverse 1 is here, pi by 4. Tan inverse infinity, I have analyzed already, it's pi by 2. But x can't take infinity, infinity comma pi by 2, where you will write? You can, there can be a point infinity comma pi by 2, infinity comma pi by 2, the point will be at infinity, which is practically impossible. When you get the idea of infinity, it gives a hint that the curve must be asymptotic. The curve must be asymptotic. You know what I mean by asymptote? asymptotic, curve is asymptotic and the line is asymptote. Here this line is asymptote and such a curve what you are drawing, that is asymptotic. Asymptote is a line which becomes a tangent to a curve at infinity. Asymptote is a line which appears to touch the tail of a curve but it will never touch. That is called as an asymptote, and such a curve is called asymptotic curve. And similarly tan inverse of minus infinity, it's minus pi by 2, but x cannot be minus infinity. Minus infinity means where do you mark? Which clearly says that it can touch the line minus pi by 2 only at minus infinity, means it can't touch. This is the tail of the curve. This line appears to touch the tail of the curve, but it will never touch. It will touch only at infinity. So this line is asymptote and curve is called asymptotic curve. Here also you see the curve, this particular line, horizontal line, appears to touch this line, but it will never touch. It will touch only at infinity. Means it will not touch. Such a curve is called asymptotic curve and such a line is called asymptote. And by looking at this comfortably, you can write what is domain and range. Or you can write any value x between, you can write a open interval minus infinity comma plus infinity. This is precise way of writing, this is okay. Any value between minus infinity and plus infinity, open interval. And range means values of tan inverse x. You know tan inverse x can take any value, but it cannot take pi by 2. The graph says it cannot take pi by 2. It takes pi by 2 when x is infinity, but x cannot be infinity. Infinity means how much? So x cannot be minus pi by 2. So it's an open interval minus pi by 2 comma plus pi by 2. So what we have written is right at the beginning.